finding all the vertical and horizontal asymptotes for the function f of x. We know that by definition, a vertical asymptote will occur if one of these two limits are infinity, which indicates that the function will have infinite discontinuity at that point. So in order for us to find all the vertical asymptotes, we will need to firstly find out all the places where the function could potentially be discontinuous. And then we check the limit of the function as x approaches those points to see if we have infinity as our limit to determine if there exists vertical asymptote. So for the function f of x, we have x squared minus 4 sitting in the denominator. We know when this is 0, the function is not defined, so it's discontinuous. So let's check out those places. X squared minus 4 equal to 0, which tells us x plus 2. X minus 2 is 0, giving us x equal to 2 or x equal to negative 2. So those are the potential places where the function is discontinuous or could have a vertical asymptote. So let's check out the limit as x approaches those places. X approaches 2 plus f of x. It's going to be limit x minus 2, right? And then the bottom is factored as x minus 2, x plus 2. Apparently we can cancel, leaving us with this limit x approaches 2 plus 1 over x plus 2, where we can just plug in to have 1 over 4, right? And then the same thing for the outside, limit x approaches 2 minus f of x will give us this, right? Same cancellation. Still give us 1 over 4. So that tells us although the function is discontinuous at x equal to 2, where the function is not defined, there's no vertical asymptote at this place. There is no VA at x equal to 2. But there might be a VA at x equal to negative 2. So let's check that out. For convenience, I'm not going to erase everything, just going to change a little bit from the board here, because the process is pretty much the same. So now we're going to check negative 2 on the right side, negative 2 plus, right? Same cancellation still applies, negative 2, right? So now we see, this is x, write it a little better. 1 over x plus 2, okay? So when we approach negative 2 from the right side, it means that x is greater than negative 2. Let's say negative 2 is here, right? Approaches from the right side. This is negative 2 plus greater than negative 2. Okay, x is greater than negative 2. So what happens to x plus 2? If you plus 2 on both sides, it's going to give you x plus 2 greater than 0, which tells us that the denominator is greater than 0. Well, this number is getting very close to negative 2, so this denominator is very, very close to 0, which is like a very small positive number, like 0.01, 0.001. So when the denominator is very small, we have the fraction turns out to be very large, and that is positive, so that tells us it approaches positive infinity. And then similarly, we take a look at limit approaches 2 from the left side, 2 from the left side, and that's going to give us same thing here, approaches negative 2 or negative 2 from the left side, the left side. Okay, so we take a look at what happens. We approach from the left side. We're gonna have x greater than, not greater than, less than -2. And then if we plus 2 on both sides, we're gonna have x plus 2 less than 0. Which tells us this time the denominator is a very, very small negative number, like -0.1, -0.01. So a very small negative number will give you a very large negative number as we take the reciprocal. So that approaches negative infinity. Okay, so after that, because you satisfy what it says in the condition, in the definition, so there is a VA at x equal to -2. Okay, so that is how we find vertical asymptotes. Now let's take a look at how we find the horizontal asymptotes. To find horizontal asymptotes, we don't really identify anything. We just simply check limit as x goes to both infinity to see if the function stabilized. If so, then that value is going to be the horizontal asymptote. So we just check limit x approaches positive infinity, f of x. That's going to lead us to x minus 2, and then this again x minus 2, x plus 2. Okay, after we cancel, we have that x approaches infinity of 1 over x plus 2. So you can imagine the denominator is going to get very, very large, and then your 1 over this denominator, the fraction, is going to be very, very small, which approaches 0. Okay, 0. And then same thing for when you approach negative infinity. Same thing is true. The denominator is going to get very large, and that's going to approach 0. Okay, so that indicates that y equal to 0 is a horizontal asymptote.